Hi, I'm Ms. Hearn. Let's get started. In this video, we're going to learn the difference between an Euler circuit and a Hamilton cycle. But first, we're going to look at some vocabulary that I'm going to be using in this video. The most basic way to navigate a graph is called a walk. A walk is any route through a graph along a sequence of adjacent vertices. On the left, there's an example of a walk. It goes from D to E, and then to A, back to D, back to E again, and then over to C. It's okay for a walk to cover the same edge or vertex twice. The only thing a walk can't do is leave the graph. For example, we could not have a walk that tries to go from C to A because C and A are not adjacent. A closed walk is a walk that begins and ends at the same vertex. On the right, we have a walk that goes from A to D, from D to E, returns to D, and then returns to A. Because it begins and ends at the same vertex A, it's considered closed. Whether or not a walk is closed is one of the characteristics that we use to distinguish different types of walks. We will also be interested in whether or not we have repeated vertices, repeated edges, whether all the edges are visited, and whether all of the vertices are visited. The types of walks we're interested in this video are all closed walks. Let's begin with a circuit. A circuit is a closed walk with no repeated edges, which can also be called a closed trail. Here's an example of a circuit. It goes from E to C, and then to A, and then to B, back to C, and then to D, and back to E again. Since it's beginning and ending at the same vertex, it's closed. It does have repeated vertices, but by definition, no repeated edges. It does not have to visit all the edges, and it does not have to visit all the vertices. So the only two requirements for a circuit are that it's closed and has no repeated edges. An Euler circuit is a circuit that visits all edges. For example, we have a circuit here that starts at E and goes to C, and then to A, and then to B, back to C, back to D, and returns to E. It's closed, but doesn't have the characteristic of no repeated vertices. Because it's a circuit, it has no repeated edges. By definition of an Euler circuit, it has to visit all the edges, and when all edges are visited, that forces you to visit all of the vertices as well. So an Euler circuit is a closed walk with no repeated edges that visits all the edges and visits all the vertices. By the way, when you have no repeated edges but you're visiting all the edges, you're visiting each edge exactly once, which is really the key characteristic of an Euler circuit. To help myself remember what an Euler circuit is, I think of the E in Euler as meaning all edges. The next type of closed path that we're going to look at is called a directed cycle. This is a circuit that has no repeated vertices. It's closed, it has no repeated vertices. Since there are no repeated vertices and because it's a circuit, it has no repeated edges, but it doesn't have to visit all the edges, nor does it have to visit all of the vertices. So a directed cycle looks like a loop. Here we have the directed cycle F goes to G, which goes to H, which goes to J, which goes back to F. Notice the difference between a directed cycle and a regular circuit is that a circuit doesn't have the requirement of no repeated vertices, so we can go back through the same vertex multiple times. A directed cycle is a special circuit where that doesn't happen. Now, the reason I wanted to talk about directed cycles is because of their relationship to Hamilton cycles. A Hamilton cycle is a directed cycle that visits all of the vertices. So a Hamilton cycle is a closed path. Just like every circuit, it has no repeated vertices. If there are no repeated vertices, there can't be any repeated edges. It does not have to visit all the edges, but by definition, it does have to visit all the vertices. So the key to Hamilton cycles is the vertices. There can't be any repeated vertices, and you have to visit all the vertices. Now we're ready to compare Euler circuits and Hamilton cycles. Remember, an Euler circuit is a circuit that visits all the edges. So we said that it's closed, it can have repeated vertices, it cannot have repeated edges, it has to visit all the edges, and by the way, if you visit all edges, you hit all the vertices as well. A Hamilton cycle was a closed path with no repeated vertices because it's a cycle. And if there are no repeated vertices, that must mean you have no repeated edges. And by definition, the Hamilton cycle must visit all the vertices, but it's not required to visit all the edges. An Euler circuit might have repeated vertices, and a Hamilton cycle might not visit all the edges. It is possible to have a closed path that's both an Euler circuit and a Hamilton cycle if it has all 5 of these characteristics. Now let's look at this example. For the given graph, determine if the closed walk is an Euler circuit, a Hamilton cycle, both, or neither. So we've been given a walk that's closed, which we can see because it begins and ends at A. It goes from A to B, from B to C, from C to D, and then from D back to A again. It has no repeated vertices, it has no repeated edges, it visits all the edges, and it visits all of the vertices. Remember, the edges are what the Euler circuit status depends on. So in this case, we definitely have an Euler circuit because it's going to visit each edge exactly once. It has no repeated edges, but it visits all of them. So it's an Euler circuit. Being a Hamilton circuit depends on the vertices. It can't have any repeated vertices, and it has to visit all the vertices. So because of these 2 characteristics, we know that we have also a Hamilton circuit. Or you can remember that if it has all 5 of these characteristics, it must be both an Euler circuit and a Hamilton circuit. Now let's consider this closed walk. So this one goes from A to B, B to C, C to D, D to A to E, and then from E back to A again. So it is a closed walk, as we were told, because it begins and ends at the same vertex. Does it have no repeated vertices? No, actually it repeats the vertex A. Does it have no repeated edges? No, because it has traveled across the edge from A to E and twice. Has it visited all of the edges? Nope, it missed A to C and C to E. And did it visit all of the vertices? Yes, it hit A, B, C, D, and E. So it can't be an Euler circuit because it doesn't visit all of the edges exactly once. Is it a Hamilton circuit? Well, for Hamilton circuits, the vertices are our focus. It does visit all of the vertices, but it repeats them. It can only visit each vertex once. Because it has repeated vertices, it's also not a Hamilton circuit. So it's actually neither. I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Ms. Hearn Mathematics, for more math videos.